All right, this is Lecture 2 webcast for Algebra course. We are recording this webcast, and I am switching over to Karen, if you're ready.
Sure.
You have to turn on your screen.
Here it goes. Okay. Alrighty. So hopefully you all can see my screen. Good morning, everyone.
We can't.
Oh, it's maybe a
There
delay
it is.
again.
There it is.
Okay.
Thank you.
No problem. Thank you so much. Appreciate it.
I'm muting myself out.
Okay. Have a good one. Okay, everybody. So again, I'm going to ask you guys kind of be patient with me as I'm trying to get used to working in the GoToWebinar and watching for your hands to be raised. What I'm going to do is I'm going to warm up today with some examples from some questions that people had issues with, and granted they're from probably the old assignments or whatever, but these are things that generally when one student asks me about something, a lot of other people have the same question. So hopefully it'll help you guys to see some of this being worked out. Okay, I'm going to start off looking at let's see, where is that problem? Okay, we'll start off with a good simple one. Okay, and let's see, I got to get my bearings sometimes with this too. This pen. Okay, here it is. Okay, problem number 1. Let me scroll down a little. Give me one sec. Okay, there we go. And all right, so number 1. Okay, so just warm up. Get your brains working. Okay, so let's go here. Okay, we want to evaluate. Someone had asked me last time about the difference between evaluating, simplifying, and solving. And I told you guys kind of just be aware of what your directions or asking you to do. In other words, be aware of what your goal is. So in this problem, I'm going to just make it number 1 here. Evaluate. Now, evaluate. Think about this. Look, the word value is in it. Okay, so we want a value to come out of this problem. So we have x plus 2y plus 3z. Now, and it's also telling us what x, y, and z are. Okay, so where x is 1, and let's see, y is 2, and z is 3. Okie doke. And so what I want you guys to get used to doing is when you have to plug numbers in for a variable, what I'd like you to do is open a set of parentheses. So where we have the x, I'm opening up an empty set of parentheses. The reason I want you guys to get used to doing it this way, go through the whole problem opening up blank parentheses where you have a variable. Okay, you can even make a little note to yourself right on top of that set of parentheses. This is where the x was, where the y, was. This is where the z was. Okay, and so what you do then go back after the fact and enter your numbers. When we start plugging in a lot of negatives values and positive mixed together, and we have to really watch our sign rules, taking this approach, what I'm doing, this process of opening up the empty sets of parentheses first, then going back and plugging in your values, that's going to help you keep your sign rules in check. And I'm going to do an example very similar to this right after, and I'll show you what I'm talking about. But look at this. Okay, so let's just evaluate. Now, the order of operations is something I just really need to I want to stress to y'all right now too, before I go ahead and do this. But I want to kind of come on the side and make a side note. Okay, order of operations. A review of this. This is a good warm-up because it's a simple concept, but it's something that we're going to use all the time, especially simplifying, solving, evaluating, whatever the directions read, you're always going to have to keep this in mind. The order to do certain operations, okay? So there's please, excuse, my dear Aunt Sally. Some of you have probably learned some other acronym for the order of operations. If you want to go ahead and throw your the ones you've learned up in the chat box or anywhere in the discussion there, you're welcome to. You know, that's kind of cool to know what other acronyms for this were. But what does it stand for, okay? And let me see. The P first is parentheses, okay? So I'm going to add to that, though. I'm going to say parentheses, and then in parentheses I'm going to write grouping symbols. Grouping symbols could be an absolute value. You might want to work inside of that first. Maybe a numerator needs to be simplified, or a denominator. So you want to work within the parts that need to be a little simpler before you can carry on to the next step. The E, then, after you've done that, we go to the E, which stands for exponent, okay? So exponents would be carried out, if that's possible, okay, or simplified. The next would be the two together, multiply or divide, left to right. It's always left to right, okay? Left to right, just like when you read. And then the two final things, let me get rid of this little bubble. A and S, of course, would be add and subtract. So you add and subtract last. Left to right, from left to right. Okay, so with this in mind, you have choices between, in this particular problem, we have addition or multiplication. So what we want to do is go through the multiplying first, okay? And this is just a 1, and we'll have a 4 plus, bring your plus signs down, and a 9. And it's pretty simple. We get 14. Now, are there any questions about the order of operations? Any questions about this? Okay. It's fairly simple, but excuse me. Fairly simple, but it's so important. It's really, if you don't follow this order of operations, and say you decided to add and subtract first, it does not come out to the same as if you've done something differently, okay? So so make sure we're following this. Let me get my other problem up. I wanted you guys to try. And look, hopefully you have your papers out. Hopefully you have a notebook open and you're writing this down with me and trying it. I really want to encourage you guys all to try your problems a step ahead of me. And, you know, just try. And I may pause sometimes to give you guys a chance to try something, you know, while we're going into our lecture, while I'm doing these problems. Okay, I'm giving myself some more space here. Okay, so let's go to part 2. And if I go too fast, you guys slow me down. Raise your hand and ask me to slow down a bit, or if you need me to go back through something really quickly, I can. So if we need to move on, you know, and we're in a hurry to finish, I want to remind you that we are recording this, so you guys will be able to go either to a link Miss Jelena would post or to our YouTube channel that I created for y'all that I'm going to post all these on, plus other videos that I make. I usually make little, for you guys, I'm making little short example videos with maybe a couple examples in it, 2 or 3. So I don't want to make them too long, but they're little snack size examples to help you guys with the tough spots, especially when I get a lot of students asking me the same problems for the same type of question. Okay, so let's go through this problem, okay? Let's try this one. Here we go. Now, I dropped my paper. Hold on. Okay, here we go. So now I want you guys to simplify this problem, okay? Notice I've changed from evaluate to simplify. okay? And simplifying, if there are no variables in something, it's going to be, you still want to do, you want to carry out the operations in the right order, okay? Except you're not solving for a value, a variable. You're not going to get x equals anything. When you're simplifying, you're merely going through the order of operations, okay, and putting an expression in the simplest form it can be in. Okay, so let's try this. Let's have, okay, come on, paper. Let's have 24. This is similar to a homework problem, but it's not exactly the same. So 24 plus, and then we'll have a bracket, -2. I'm going to put an x in there. I don't want to trip y'all out, but yeah, there we go. We're having variables. I'm going to put it in there right away. Okay, open and close another bracket, and we'll put -10 right there. Okay, and oh, I forgot, I need to put a square on this 10. Okay, now we have something to work with. This is something good to chew on here now. Order of operations is really going to come into play here. All right, so what's first? Parentheses, right? Okay, well, typically what we would want to do, we want to go and look inside of this, inside the innermost set of parentheses or grouping symbols, and say, you know, can I simplify this anymore? And so, no, we can't. We don't know what x is, so we want to keep it just the way it is. And so what we're going to do with this is we are going to leave this. We're going to bring it down. Well, we're not going to bring it down, but we're going to go outward. So we work our way outward to this -2, which is going to be distributed into this x plus 2. Most of you know how to do this, so here, if you need help with this, this is a good example of distribution property. So we bring down all the parts we're not dealing with. I don't want you guys to just bring the part you're working on down. Bring everything down together, structured. Keep it in the structure that it's presented to you in. That is the best way to go about this. Now what I'm going to do is I'm going to open a set of parentheses here in place of this bracket, okay? And I'm going to distribute the -2, so we'll have -2x. And yeah, I'm being long-winded because I'm hoping you guys are working on this too. Okay, so -2 times x is -2x. -2 times +2 would be -4. Okay? Now, next, let me bring this down, okay? And you could probably handle a couple of the steps of order operations in one step sometimes, but for our sake, for this, at this point, I'm going to bring it down and do one part at a time. Now, do I need these parentheses that I have? No, I don't. But I also don't need a plus sign, and I don't need a subtraction together. But you can do this. This is not distributing this negative. You want to be very careful with your signs. That minus is just on the 2x. So you could write it as, you could go ahead and write something as -2x, you know, in the scope of things. Let's see, 24 minus the 2x, or you could write the 24 plus a -2x, and, you know, keep the -4 just the way it is. You know, I'm just kind of showing you guys options, so just to kind of give you guys a little idea of what you can do. Remember that subtraction and adding a negative or equivalent forms, okay? And so here we go. So we can write, not that, my pen goes nuts sometimes. You guys ought to get a kick out of that. Feel free to giggle. So we'll put -2x minus 4. In this step now, I'm going to go for the exponents, right? So exponents would be next. We want to carry out this, okay? And so what is 10 squared? And we want to bring that subtraction down. 10 squared is 100, okay? Now, remember this. I'm going to do a short example when we're done with this, but I guess let me come back to this so in a sec, okay? I'm going to I'm going to make note of that a sec, okay? Put a little asterisk on this, okay? More in a minute. I'm about to get to one. That's going to be one of my favorite examples I show my students every time. So, okay, now we have this minus 2x is kind of like a sore thumb sticking out amongst numbers that are just constants, right? They don't have a variable attached. So I'm just going to kind of put that up front, minus 2x, get it out of the way. And I'm going to go ahead and combine my 24 minus 4, which is what? 20. And then 20 minus 100 will be what? Negative what? 80. Good job. Okay. So now we're done with this problem. So let me come on the side here, and I want to do just a little short little series of examples to kind of get you guys thinking about this issue here, this minus 10 squared. Some people might be thinking to themselves, wait, it's negative 10 being squared, right? Wrong. Okay, be careful. I'm going to show you why with a little short example here, okay? Let me get my little sketch pad a little closer. Okay. So, let me see, okay. So here we go. This is more on that. So here comes. All right. So a little something to think about. All right. So food for thought. How does an exponent work? Okay. An exponent applies to what it's directly attached to. So when I have some base raised to the nth power, remember the base is raised to the exponent, right? The exponent applies to whatever it's directly attached to. So n is attached to the base. Okay? So then in this case we would actually multiply b times whatever times b, what? N times, right? Okay. Knowing that, now consider b, let's say b was even a set of parentheses, for example, okay? Now I'm going to ask you guys to do a short series of examples to kind of make my point. I think it's better just to show you guys than anything else on this one, okay? So let's just have example, sub-example A. Let's have 2 to the 4th power. Okay, going by this definition, I need to multiply 2 times itself 4 times, right? Of course, we get 16. Now, example B. Let's put negative 2 in parentheses raised to the 4th power. Note, what does the 4 apply to? The 4 applies to whatever symbol, number, or grouping, whatever it is, whatever thing it's directly attached to. So, for this problem, it's attached to the parentheses, so whatever is grouped together inside of those parentheses is what needs to be written as repeated multiplication 4 times. Okay? All right? And of course, when I have an even exponent, okay, and I'll show you why here, notice when I have an even exponent, I'm going to always get a positive result, okay, for even whether I'm raising a negative number or a positive number, okay. Here's why, okay. I'm going to come down here right on the bottom of this and kind of make a little note. What is negative 2 times negative 2? It would be a positive 4, right? Okay, put a little multiplication dot there. Okay. All right, and then negative 2 times negative 2, positive 4. And of course, positive 4, in the end we'll get a positive 16. So notice negative 2 to the 4th power, positive 16. Now, let me try to throw you a little bit, okay? And at this point, after I write this problem, if you go back and watch the video, pause the video, and maybe try this one yourself, okay? And so I'm just going to write the negative 2 to the 4th power just like this, okay? All by itself now. Be careful. Excuse me. Now, what is the 4 applying to? What needs to be repeated? In other words, 4 times being multiplied. It's applied to the 2. So what about the negative sign? So in other words, what you're going to do with this, okay, you can bring over or bring down the negative sign, okay? That is not included in my 4th power. And then I'm going to just kind of do this. I'm going to group into parentheses what the exponent is applying to. Just for your sake right now. I mean, in the future, hopefully you'll just be able to do mental math, and this will be done in your head. So the 2's are the 16, right? So bring down your negative. So so how we would read these, let me kind of go back and reread these for you the way I think you would need to interpret it. Of course, this is 2 to the 4th power, right? Okay. A is 2 to the 4th power. That would be positive 16. Okay. And then B, this would be negative 2 to the 4th power. Of course, that's positive 16. And then C, I would say this, the opposite of 2 to the 4th power. So the opposite of what? 2 to the 4th power. And that's exactly what I wrote. I did the opposite and then 2 to the 4th power here. Okay? So is negative 16, right? All right. Are there any questions on this? Let me go look in my question box and see if anybody's, yeah, I see one. Okay. Final answer. Oh. Okay. All right. I have a question about the previous example. It's the question on the first problem about the negative 2x minus 80. Someone asked me if the directions would read to solve that. Okay. Let me get rid of my question box here. Okay. No, the oh, I see what you're talking. You're talking about a different problem. Okay. No, the oh, I see it. Wait, hold on. I'm sorry. I'm like totally going way too far back. You're asking about this guy. Okay. So no, it won't be this problem. The way it's given to you here, this should never have the direction solve written with it. Okay. The reason being, solve is reserved for equations or things that we need to find a variable. And I'll give you one of those right now, a simple one, just to kind of exhibit that. We solve equations, okay? We simplify expressions. And let me show you what I'm talking about, okay? So let me write, you may want to write this note. Okay, we solve equations. Now, what is in the word equation? Equal, right? The equal sign. In other words, when the problem's given to you, it should have two things equal, two expressions containing a variable. It should be written like that, okay? For example, we could be asked to solve this problem. Let's see. Negative 2x equal to 3 minus 5x. Okay, and actually let's just make it positive. 3 plus 5x. Okay, now notice I have two expressions set equal to one another. I have an expression here set equal to another expression. This is an equation. This is something where we can find a solution for x. Okay, and also technical term, we can find a solution set that would make this equation true. In other words, what value of x makes something equal to itself, makes a true statement happen, okay? And so we would go then and start to isolate x using our properties of equality. And in a nutshell, what the properties of equality are saying is just this. They're saying to keep the scale balanced. You want to think of your equal sign, okay? You want to keep the scale balanced. My pen is doing its weird stuff again. I'm sorry. All right. Sometimes I just have to like be patient with it. Balanced. Okay, so here's your scale. All right, so let's kind of do a little picture of a scale. Okay, so here's my little thing that I'm trying to balance, okay? It's my little scale plates. Think of an old courtroom scale. Okay, now I have, all right now as it is, I have it balanced, right? I have this, let's say I have 1, 2, 3 pieces of gold in here, and I have 3 pieces of gold here. If I would take out one, let's say, if I would take one of these out, what would happen? 2 is not going to be 3, right? So this would unbalance the scale. Okay, so we don't want to do that. We need, if I take one away from the left side, I need to take one of these out of the left side too. Oops, I didn't want to take the whole plate. All right, so what I do to one side of the equation, I need to do to the other side. So if I take a piece of gold out, I need to take another piece of gold out on the other side. If I add 3 pieces of silver in on the left, or whatever it is, I need to also put in those to balance the scale on the other side of the equal sign. So you get the point. So what I'm going to do now, and all that is, the goal is to get x equal to some number, okay? That's all in this process of trying to solve. So I'm going to go ahead and solve this for you now, okay? So let me kind of get us some room here, okay? And so, there we go. That's better. So I want to get x by itself. So what I need to start doing now is getting all my x terms on one side. And people typically like to move the x terms to the left and all the numerical, the constants to the right. So without x, if it does not have an x, move to the right. If it has an x attached to it, move to the left. So I'm going to move this 5x. Now it's added. How do I get it to move sides? That's when I use the inverse operation. So if 5x is added on the right, both sides will have it subtracted. Now, it's legal, it's okay to do as long as you keep it balanced. Okay? So what I did to one side, I'm doing to the other. So now my next step. This is why it's really good to skip lines in your homework when you're working out problems, because especially when you do this style of solving, you can keep your scales balanced in between the lines. It helps you. So now negative 2x, negative 5x, that's going to be negative 7x. This is my new left side of my equation. Now these guys cancel, right? The negative 5x and positive 5x. And I'm left with just the 3 on the right. Okay, now remember to keep the scales balanced every step you go, okay? Every time we're trying to move stuff around each side, that's what I'm doing here in between the lines. Now I have negative 7 multiplied times x. What undoes multiplication? Okay, now also what you can think of is this. Just kind of remember that negative 7 over itself. These guys would cancel to 1, right? Really, we want 1x. We just want x. Okay? So if I would divide both sides by this -7, here we are, keeping it balanced, both sides, right? Be careful with your signs, okay? So your signs will kind of cancel and go positive. Your 7s cancel to 1. And we are left now with x on the right, on the left. Right now we have x all by itself. And the right side, excuse me, is going to be -3/7. Now, another point I can make here is, can I leave the negative sign in the denominator? See up there in that step where it's in the denominator? No, we don't ever want to do that, okay? So you can answer when you have a negative fractional answer, whether it's you have variables in your problem or not, this goes, okay? This is always going to be the case, okay? Unless you're trying to work within a problem as part of, you know, getting to a solution, but as presentation, I guess, is everything, so they say, you can either answer this with this negative attached to the numerator, in this case the 3, like I have it already, or you can put your negative sign out in front of the fraction bar. Either way, but you don't want to leave it in the denominator, so you don't want to leave it like that. So don't answer it like that. It's not technically wrong, it's just not in the correct simplified format. Okay? All right. So let me kind of put an or instead of the equals on there. Yeah. Okay. So or. All right. So either of these would be correct. Okay, I got another question. Let me go to that one. Let's see. Textbook page 54, independence practice number 12. Okay, I probably have that. Let me see that. Let me get that out. Okay, I have it right here. Okay, Vivian's asking me to go over a problem on page 54. So Vivian, let me get that real quickly, and I would be happy to do that. Let's see. Oh, you know what, Viv? I do want to go over that one, but I need to do a couple of others to warm you up first, okay? So yeah, I'm going to get to that. Okay, so let's see. Yeah, okay, let me see. The fun. All right, so I don't see any other questions. I'm going to go on to the next example then, okay? All right. And I need to spill my drink. Okay, the next problem I want to have a look at. Okay. All right, here we go. Here's a good one. Da-da-da. Come on. Make some room. Oh, solve equations. I think that I needed to put one more note. I forgot to put simplify expressions, okay? All right. Let me kind of just show you what I was talking about. I'm going to finish that point. Simplify expressions. Or you may be asked to evaluate an expression, in which case that would have been like our very first, number 1. The very first one was evaluate. This was an expression, okay? Let me make that note. Because notice, this was given to you. It's not set equal to anything, right? This would be an expression. Okay? So expressions versus equations. That's what the deal is. So let's simplify one more expression. And this one will contain, well, I'm not going to put that just yet. I was going to put variables in it. Not just yet. Hold on. Let's see. Let me get this one out. Excuse me. Okay, here it is. Okay, so, come on, pen. simplify this expression. Give me a sec. Sorry, guys. Okay. So let's have this 3x plus 5 times x minus 4 minus the absolute value of -2, and that's it. Okay. So notice the two vertical signs between two items. Okay. I kind of need to call your attention to this. Okay. We didn't have a chance to talk about absolute value very much the other day. But absolute value as defined, absolute value is the distance a number is from 0. Okay? You may have learned or have heard in previous classes simply that absolute value is just the positive version of a number. It's a little more than that, okay? So just kind of, this is the correct definition of absolute value. And let me put that over here. Note to selves, please make sure you remember this too. The absolute value of a number, okay, is a number's distance. Okay, Karen. A number's distance from 0. Okay. On the real number line. Okay. And the reason we define it this way is because a distance, when you have a distance, think about the sign rules. Okay, now, can I ever have a negative distance? If I drive from New Orleans to California, if I drive from New Orleans to Simi Valley, my sister-in-law lives there, then I'm going to travel many miles, right? Okay, let's just, I'm not sure how many miles, let's just say 1,000 miles. If I travel 1,000 miles on the way, okay, and then I travel 1,000 miles going back home, did I somehow go 1,000 negative miles? Did I go a negative 1,000 miles? Is that possible? No, okay? No, my car's odometer is still going to register 2,000 more miles it traveled, right? So it's going, my car is telling me you've traveled 1,000 miles to get there, and you're traveling plus 1,000 more to get back home. So you cannot have a negative distance, okay? This is why absolute value turns a number, a negative number, into a positive number, okay? So just kind of FYI, in case you were up all night wondering about absolute value, now you know, and you can rest well tonight, knowing the real definition of absolute value, okay? So here we go. Let's go down the line and let's simplify this expression. Okay, so grouping symbols, we don't have to worry about just yet because look, inside the parentheses there's an X, and I don't know what X is. So actually, this would be simplified, right? It's as simple as it's going to get for now, the inside of the parentheses. Although the absolute value grouping symbol can be figured out. I can work the absolute value of -2 because now I know the definition, right? So like I said before, bring down all parts that you have not worked on yet, okay? And simplify, you know, a little bit at a time. Use some paper, guys. Don't try to compact one problem into a square inch of your notebook paper. That's not going to help you, okay? Give yourself ample space. Okay, so by the way, look, I brought this negative down, and so this guy turned into a 2. Okay, give yourself space, okay, and like I said, skip lines, so you can either make notes or draw little, like grouping, like little things that you can go back and help yourself, your future self, understand what exactly you did here. Okay? Okay, and yeah, a lot of, this is some of the best advising I've ever heard as an instructor tell a math student. You want to write your notes as though you're going to have to teach your future self later on. Okay? And that is true, because you probably will. You know, it's practice, but you're going to have to show someone how to do this stuff. Okay? So next we're going to go ahead and distribute. So we can get rid of the parentheses. And so that kind of goes into multiplying, okay, multiplication. So we're going to multiply 5 times the x minus 4. So the first distribution is 5x. And then 5 times negative 4, which is negative 20. Watch your signs. Bring down your minus 2. Okie dokie. So now we want to combine like terms. Remember, like terms have the same, exactly the same variable ending, okay, or no variable ending, okay. In other words, the x terms, the exponent has to match as well, okay, and we'll get to some of those eventually. So just kind of keep in mind the entire variable ending must match. So here we have 8 x's total. So negative 20 minus 2. If I owe you $20 and I borrow $2 more, then now in total I owe you 22. Okay. So this is the simplified version of that expression, okay? So notice I did not end up with x equal to anything, but I merely went down the line using my order of operations and created a more compact, easier to read version of that original expression. That is simplifying expressions. Okay? And so remember, solving an equation, we're trying to get to x equal to something, right? In this case, we were getting to x equal to negative 3/7. You see. Okay, so solve equations, simplify expressions. And from time to time, you may have to evaluate. That's when we give you the values, as in that other example. Okay, so now let's move on to that other problem. And I need to watch my time, and so I'm going to try to get to that one, though. I wanted to go over this one. Let's go over one where we have to find a common denominator, okay? And actually, Vivian, I may have to save that one. That's kind of a long problem. Would it be, hopefully, would it be okay with you guys if I save that one for a future lesson, that number 12? I do want to do it. I tell you what, I'm going to record a video after of just that example for anybody who wants to see it. I don't want to go, it's kind of more advanced. I don't want to confuse anyone with that. So I'm going to record a special video of that number 12 on page 54. And it'll come out this afternoon. It'll come out next, okay? I want to look at some exponent rules. We talked about that quite a bit the other day. So let's kind of take a look at something that kind of matches up with your homework. Let's see. Here we go. I'm going to do this one. All right. So what number am I on? Let's see. All right, kiddos. So 1, 2, okay, so this would be 3. This was 3, and that one was 4. So this would be example 5. Okay, I'm keeping them numbered because it helps me to time. So technically, and the other one was on the side, so we'll leave that on the side. So, okay, notice this one's going to read simplify using your exponent rules. Okay. So on this one, oh, let me get that problem. All right. Remember your exponent rules. I want to just kind of remind you of those basic exponent rules. Okay. Just to kind of review quickly, I'm going to give you just the basic ones. Okay. The two people confuse the most would be these. Okay. If we have a base to the m power multiplied, okay, there you go. I think it thinks I'm trying to make a bullet. Multiplied times the base to an n power. Okay. Notice the bases match. If what's being raised to the exponent matches, okay, then we add our exponents. Okay. An example would be if I have x squared times x to the 5th power. That would be x to the 7th, right? 5 plus 2. Okay. The other one, the other basic rule, property or rule that people confuse this one with is when I raise a base to 1 power and then that gets raised to another power. So I'm raising a power to another power. These two get confused the most. Okay. What I do in this case is I multiply the exponents. So then I would have b to the m times n. Okay? And so if I have x squared raised to the 5th power, okay, so I'm still using a 2 and a 5 just to kind of show you. It's 5. Then I'll have x to the 10th power. Okie dokie? So don't confuse those two guys, okay? So two little sub-examples. Now let's kind of go to this, another example. It's going to kind of be real similar. Also, when you have an exponent property, an exponent rule problem, okay, it's not fully simplified if you have negative exponents. So you want to make sure all your exponents are positive. So here's this one, okay? Give this a shot. Open parentheses, let me make that look like a parenthesis. Open parentheses, 3x to the negative 3rd power squared, outside of those parentheses, times 5x. Okay. Now, a lot of good points in this problem. Okay, so this is the problem. We're trying to simplify this with our rules. Okay. So first off, we want to take a look at the power to a power. Now, you could go ahead and make your exponents positive or whatever first, but it doesn't matter at this point. At this point, it actually would be simpler to kind of take care of these guys first. Okay. Now, notice that earlier I talked about the exponent applies to what it's attached to. So I'm actually not just taking care of the negative 3 and the 2. I am actually, let's see, come on, you can do it. Okay. Actually, I am taking care of 3 being raised to the 2nd power and x to the negative 3 being raised to the 2nd power. Because this 2, this outside 2 exponent, is attached to parentheses. So whatever is grouped inside of these parentheses, that is what's being raised to the 2nd power. So every factor, everything in that inside group of factors gets raised. Okay? So let's kind of put that step, okay? So what does that look like? I'm not going to carry it out, but I'm going to write it out for you. So 3 will get squared times, no bullet there, okay, times x. Now negative 3 times 2, right? Power to a power, we can go ahead and multiply and get negative 6 for our new exponent on x there. And then we'll bring this guy down, negative 5x. Okay, not so bad. Okay, we're working on it. Yep, it's getting there. Now what I'm going to do, okay, now what I'm going to do is, this is just a bunch of stuff multiplied, okay? Go ahead and carry out this 3 squared, okay? All right. Oh, let me get rid of that. I didn't want to really underline that. So go ahead and what's 3 squared, okay? Let's go ahead and do that one. Oh, go on, pen. There you go. So 9 times, okay? I'm going to bring this 5. Now remember, I have a list of things. Let me go ahead and rewrite it like it is. Multiplication is commutative, we had said. So I can go ahead and reorder this any way I like, okay? So if I want to write the 9 and the 5 first and multiply them, I can. And then if I want to put the x to the negative 6 times x, by the way, if there's nothing there, it's implied to be a 1, right? So kind of remember that. Okay, so now I'm going to take care of these guys in this manner. Let me give some room. So here I can say 9 times 5 is 45. Okay? And here is that very first rule, right? This guy says if the bases match, which they do, I have x and x, then I can add the exponents. So I'll just take the negative 6 and the 1, and they get added. So negative 6 plus 1. Or what? What is that? If I owe you $6 and I only pay you back 1, how much do I still owe you? I still owe you $5, right? Okay. If you're kind of still getting good at the subtracting and adding the negatives and all that, think about it as money. It helps. Believe it or not, it really helps. Now, is this totally simplified? Not yet, right? Who's the problem child? Okay, this is a problem right here. It's not exactly a problem, but it is stopping this problem from being fully simplified. Okay, remember that we can put all this stuff over 1. Anything, you can make anything look like a fraction by slapping it over 1, right? So anything that's not in fraction form, any number or expression or anything similar to this, put it over 1. Okay? So if you were worried about crossing the fraction bar to make this negative 5 positive, you know, don't worry about it. There you go. It's there. It's just not pictured until you put it there. So finally, we had talked about this the other day. This is this rule here. Okay, give me a sec. All right. So we have this rule. Okay, it says that if I have a to the negative m, okay, now just kind of picture that over 1, that if I reciprocate, right, I take the reciprocal, it negates the exponent, okay? And then also in the other direction of that, let's kind of, if I had that 1 over b to the negative n, okay, I can cross up into the numerator and make b to the positive n, okay? Similarly, one more thing I'll add there, if I have a over b to the to the negative m power. This is telling me to reciprocate, right? Then this would be in parentheses b over a to the positive m. Okay? So here we go. Enough of that. You can kind of review your exponent rules. Let me know if you have more questions about that. So this guy's got to go downstairs, okay? And then we'll be pretty much done. So 45 stays upstairs. X to the positive 5, right? X to the positive 5th power is in the denominator. And now we are done with this problem. And I think we're almost out of time. I have time just maybe for 1 or 2 questions. Let's see. Yeah, I'm definitely going to record that number 12 for you. I did it for someone yesterday, so I have it all worked out. And I'll even include those good side notes that I gave you. So hopefully that'll help. Yeah, there's a lot of good stuff in that problem. So be on the lookout for that. it'll be on the YouTube channel, and I'll also put another link in the general forum for you guys for the playlist if you haven't found that yet. Okay, I am adjusting deadlines and all that, you guys, so we're trying to get it all straightened out. I want you guys to know that. Just be patient and know that I really do appreciate your patience. There's also in the general forum, I put a little note about like where to put certain inquiries, you know, when to use email, when to use forum. And yeah, save me some problems for our lecture, because I like it when you guys ask questions. It makes me a better instructor. So help me help you, and you can be a hero. All right, you guys, I think that's it for today. Hopefully, thank you guys. I see your comments. I appreciate that a lot. You guys have a great day, and I'll be in touch, and I'll talk to you guys soon. Also, your homework is due tonight. That's right, at 11:55. Really quickly, yes, okay, on the day a lecture opens, or a lesson opens, that night is when you'll be handing in the previous homework, okay? So like to this morning, we had a new lesson open, right? So then tonight, you'll be handing in what you have been working on from last assignment. Is that understandable? Is that good, you guys? Does that make that clearer? No problem. You're very welcome. I don't mind answering that. Cool. Thanks. I'm glad that helped. Okay. So, yeah, spread the word. You guys, if not everybody got to attend today, so, you know, a lot of these questions that are getting on the board and all are getting answered in these sessions, and that's good. So maybe tell people, go look at the recording. You'll get some examples, and you'll get your questions answered too. Double help. You guys are awesome. Don't forget that, and have a great day. Talk to y'all soon, okay? Later on.